Hello, this lesson is going to be over trigonometry. Trigonometry is basically the study of sine, cosine, and tangent. There's three others called cosecant, secant, and cotangent, but we're not going to really get into those. You'll dig really deep into those when you get into pre-cal. For trigonometry, there's three that we need to focus on. That's sine, cosine, and tangent, and you can see those right here. Sine is basically a function, and the sine of A is equal to the length of the leg that is opposite angle A over the length of the hypotenuse. So if you look down here at this bottom triangle, if we're trying to find, say, the sine of angle A, well then that's going to be the opposite, which is, in this case, A, over the hypotenuse, which is C, and you can see that right here. Cosine of A is the length of the adjacent side to angle A, in this case B, over the hypotenuse, which is C, so B over C. The tangent is opposite of angle A over adjacent, so A over B, which you can see right there. You can abbreviate those and not have to write those every time by this right here. And then there is an acronym that can be used to help kind of remember these, because you'll have to have these memorized, and that's what we call SOHCAHTOA. And SOHCAHTOA is an acronym, so S stands for sine, C stands for cosine, T stands for tangent, O is opposite, H is hypotenuse, A is adjacent, H is hypotenuse, O opposite, A adjacent. So SOHCAHTOA is basically something that you can remember, and when, like, on your test or on your assignment, you can just write SOHCAHTOA, and it will be basically a tool to use for any kind of question related to trig. So let's say, for example, here's our triangle, and they called this theta. Theta is this little symbol with the 0 with the slash through it. It's a Greek symbol. It's usually used with trigonometry, so you will see that again when you take pre-cal. Let's say, for example, that we had this triangle, and this was A, this was B, and this was C. The sine of theta is opposite over hypotenuse. This is opposite, this is adjacent, this is hypotenuse. So that's going to be A over C. But let's say we had that same triangle, and theta is up here. Same markings, A, B, and C. Well, now the sine of theta, I'm sorry, this is kind of sloppy. The sine of theta is, here's opposite, here's adjacent, here's hypotenuse. Now it's B over C. So it's important that you find the location of the angle measure when you're doing trig ratios in order to make sure that you write it correctly. Remember that this can only work if it's a right triangle. And basically it's used to write the ratios, so that way you can find a missing side length, or you can find an angle measure. So SOHCAHTOA is a useful tool when you have those kinds of questions. On the SAT and the ACT, SOHCAHTOA will be helpful because they're going to ask you simple questions like I'm going to do in a second, and you can take 5 seconds to answer the question rather than going through and doing another method to solving it. So the first example I have here is writing trig ratio. So this is just practicing writing the actual ratio. And it says, what are the sine, the cosine, and the tangent ratios for angle T? This is what's important, because now we know where theta is supposed to go. You don't have to write theta there, but I like to sometimes just because it kind of helps me see what I'm looking for. So my next step would be to label my triangle. So I know this is my opposite, I know this is my adjacent, and this is my hypotenuse. So the sine of T is equal to opposite over hypotenuse, so write SOHCAHTOA up here for you, SOHCAHTOA. Oops. SOHCAHTOA. Sine is opposite over hypotenuse, so that's 8 over 17. The cosine, we abbreviate cosine as COS of t, is adjacent over hypotenuse, that's 15 over 17. And then tangent, which we abbreviate as TAN of t, is opposite over adjacent, so 8 over 15. Now in each one of these right here, if you can reduce it, you will. If the question asks you to write it in decimal form, you will just put that in the calculator, 8 over 17, and then you'll get your decimal. Otherwise, you can just leave it in the fraction form. But basically, if you're asked to find the sine of a particular angle measure, and they give you the side lengths, this is what you're going to do. Alright, our next example here says, in 1990, the Leaning Tower of Pisa was closed to the public due to safety concerns. The tower reopened in 2001 after a 10-year project to reduce its tilt from vertical. Engineers' efforts were successful and resulted in a tilt of 5 degrees, reduced from 5.5 degrees. Suppose someone drops an object from the tower at a height of 150 feet. How far from the base of the tower will the object land? So what we have here is a triangle that looks something like this. It's a right triangle. This is 5 degrees and this is 150 feet. And that is coming straight from the picture. So we're trying to find the bottom part. Now the first step is to figure out how the side lengths that you're given are related to the angle measure that you're given. In this case we have the opposite and the adjacent. So we would use tangent. So our formula is going to look something along the lines of tangent of the angle measure. So tangent of 5 is equal to opposite, which is x, over adjacent, which is 150. Now when you do this problem, you have to make sure that in your calculator, your mode is in degrees. And in order to do that, if you're using a scientific calculator, which most of you would use that in class, you would have to click the mode button, which is the second one on the top, and then you would change from radian to degree. That would be the third thing down. You would make sure that the degree is highlighted, and then you would be able to do this problem. If you have an iPhone, when you tilt your iPhone to the side, you'll see sine, cosine, and tangent, and you can use that as well. It's already in degree mode, so it will work. If you don't have that, you can also go on my website if you can access it. I put it on my Remind 101 account for you guys the other day. And you can, on there I have a link to an online graphing calculator. And you can use that and you can do these problems if you need. So in this case, this becomes an algebra problem where you're just going to multiply both sides by 150. And then so you get 150 times the tangent of 5. And that's going to equal x. So you're going to put that this into the calculator, and when you do that, you get about 13 feet. And so that would be your answer. Okay, so tomorrow I will show you guys how to do a question where the x is in the denominator of similar to the problem I just did, because it's going to be a little bit different in your algebra, but it's pretty simple in the steps. So I will show you guys at the beginning of class. So these last two examples that I have here are finding the angle measure, and this is where we're going to use what's called inverse trig. So we're going to use the inverse sine, inverse cosine, inverse tangent. Now to do that in the calculator, you're going to need to press the second button and then press the trig button. So like for example, if you're doing inverse sine, you'll press the second button, which is the yellow key, and then you'll press sine. And on your screen, you'll see SIN with a little -1 exponent, and that means inverse. In order to find the angle measure, like what we're having to do on both of these questions, you're going to have to do that. So the first thing is to figure out, based on your angle that you're looking for, what the sides relationships are going to be. So I see here on question A, the first one, we have opposite and we have hypotenuse. So what that means is that we're going to use sine. So right now we know that the sine of x is equal to 6 over 10. Well, in order to solve this question, we need x by itself. And the only way to get rid of sine is to take the inverse of it. So we're going to do the inverse sine of x. So, oops. And that is going to, well, we have to make sure, like in algebra, if we do it on one side, we do it on the other. So what's going to happen is the sine inverse and the sine are going to cancel, and we're just going to get x equals. And then we plug this straight into the calculator. So second sine, and then the fraction 6 over 10, and then we round to the nearest tenth, because it's the to the nearest whole number, because it's a degree, unless it specifically says tenth. So this would be about 37 degrees. So the bottom question, same thing, angle y. We're given opposite and adjacent this time, so we're going to use tangent of y is equal to 100 over 41. We're going to take the inverse tangent of both sides. And notice that in the question above, I put sine of x in parentheses in the last step. It doesn't matter if you do that or not. It's not going to make a difference. I didn't put them around the second one. That's not going to make your problem wrong. So don't worry about the fact that I did parentheses in the first and not in the second. So in this case, we would do second tangent, 100 over 41. And that is going to equal, I believe it was 68. Okay. So there's your trig. I will also tomorrow go over a little bit about cosecant, secant, and cotangent, just so you can kind of get an idea of what it is and how it can be used. But make sure that you have all these down tomorrow. Remember that getting access to these videos means you can pause, you can rewind, you can rewatch. I know that there's some students who told me that what they do is they go through and they copy everything down first, and then they go back and rewatch the video. So if you have any questions, just come see me in the morning or at lunch after school. I'll be available to help out however you need. Have a good evening.